All right, geometric sequences. So elephants, my newest obsession, understand and conceptualize death in a deep and emotional way and have semi-ritualistic such religious practices to mourn their death of their fallen friends and family. Isn't that like, it's really cute, but it's also like sad, but really cool. Like they're like the smartest animals. Okay. Behind ravens, like I feel like every time I start learning about new animals, it's like, wow, they're the smartest. But then you learn about someone else, it's like, whoa. I mean, in real life, my dog Aldebaran's the smartest. He's actually the dumbest. Okay, so in a geometric sequence, each term is found by multiplying the previous term. So arithmetic we talked about where you're just adding. Well, geometric is where you're multiplying to get the next term, okay? So the sequence in which the ratio, we call it the ratio now instead of like the difference, between any two is constant. You're multiplying by the same number. Okay, so the common ratio, the numerical ratio between any two terms is represented by R. We just use R for that. Okay, so if we want to determine whether it's geometric, and then we want to figure out what the common ratio is. So this one, an easy way to figure this out is if we just let's do 10 divided by negative 2, and we get negative 5. If I do negative 50 divided by 10, I get negative 5. If I do 250 divided by negative 50, I get negative 5. See how I'm getting negative 5 each time, and I'm just taking these and dividing them. That means that, yes, this is a geometric sequence. The common ratio is negative 5. So then the next three terms would be negative 1,250, 6,250, negative 31,250. Okay, let's look at this one. So if I do this one, if I do 8 divided by 4, I get 2. If I do 20 divided by 8, you get like 5 halves. Those are not the same thing, which means that this is not a geometric sequence. Nope, don't like that. Okay, this one. So 8, 10, 270, 90, 30. Well, if I divide those, what is that? I think it's 3. Yeah, it is. So 8, 10 divided by 270 is 3. 270 divided by 90 is 3. 90 divided by 30 is 3. So that is absolutely a geometric sequence. And the ratio, it's 1/3. I was saying that wrong. So, because if you do 270 divided by 810, you get 1/3. 270 divided by 90, you get 1/3. 30 divided by 90, you get 1/3. We always want to take the second one, why won't it let me write, and divide the first one. Okay. So then the next three terms would be 10, 10/3, 10/9. Okay, so the nth term in any geometric sequence can be found using this formula. So a sub n equals the first term times the ratio raised to the n minus 1 power. Okay, so let's write a rule for each of these sequences and then find the sixth term. So like this one, a sub 1 is 1, r is 5, so then I can write a formula for this would be a sub n equals the first term, so 1, times 5 raised to the n minus 1 power, which is really just 5 raised to the n minus 1. So then if I plug in 6, that's a sub 6 equals 5 to the 6 minus 1 power, which is 5 to the 5th power, which is 3,125. So this kind of like, this blows up. This sequence is going to get really, really big, really, really fast. And that's typically what happens with these. It either blows up or it gets really, really small and approaches something, okay? Now I get it. Okay, so 310, 65, 320, 32.5, 16.25. My A is 1, and my common ratio is 1/2. And you can get that by doing 65 divided by 130, or 32.5 divided by 65, so on. Okay, so my formula is a sub n equals 130 times 1/2 to the n minus 1 power. So if I want to find the sixth term, that's 130 times 1/2 to the 6 minus 1 power, which is 130 times 1/2 to the 5th power, which I just used my calculator at this point, and I got 65/16 or 4.0625. Cool? Mathematical. Okay, this one. So we want to use the information to find the indicated value. Well, in something like this, we're given the first term, we're given the ratio, and we could literally just plug this into the formula. So a sub 8 equals 7 times 4 to the 8 minus 1 power, which that's 7 times 4 to the 7th, which is 114,688. Whoa. Awesome. I literally, okay, when I was putting this meme on here, I was like laughing out loud. I thought it was so funny. Okay, anyway, so if we have a sub 5 equals negative 68 and r equals negative 0.5, and we want to find a sub 1, we kind of have to work backwards here. So if we have a sub 5 equals negative 68 and a sub 1, so let's plug in a sub 5. So I'm saying n equals 5. So I have a sub 5 equals a sub 1 times r to the 5 minus 1. So up in this formula up here, I'm just saying, well, let's let n equal 5. Okay. Now, I know what a sub 5 is. It's negative 68. Oh, I just did 5 minus 1 is 4. But then I know what a sub 5 is negative 68. And I know what r is. It's negative 0.5. So then I can solve this for a sub 1. So I get negative 68 equals 0.0625 times a sub 1. Divide by that negative, or divide by 0.625. And you get negative 1,088. Yes. Okay, these memes are stupid. Okay, next. Okay, so a sub 1 equals 13, and a sub 4 is 4,495, 59, I meant. And we want to find a sub 3. So we have to do this in 2 steps. We have to find r first. So to find r, I have a sub 4 equals a sub 1 times r to the 4 minus 1 power. So that's r cubed. But now let's plug in what we know. So I know 13 is a sub 1, and I know 4,459 is a sub 4. Now I'm going to divide by 13 to both sides. And I get 343 equals r cubed. Cube both sides, cube root. And you get r equals 7. Now if I want to go find a sub 3, I can just do a sub 3 equals 13 times 7 to the 3 minus 2 power, which is 13 times 7 squared, which is 637. Cool? Wahoo! Okay, this one is a little trickier. So if we have a sub 2 equals 6 and a sub 5 equals 0.048. Now, if I look up in my equation, I need a sub 1. Okay, I need a sub 1, but let's write this out. So that would be like a sub 1, and then a sub 2 is 6, a sub 3, a sub 4, a sub 5 is 0.48. Let's just pretend like we didn't read that, okay? And let's say a sub 1 is 6 and a sub 4 is 0.048. Okay, we're just going to like shift this and pretend that we know what a sub 1 is, okay? Now let's go plug it in and do the exact same thing we did on this other equation. So we're going to have a sub 4 equals a sub 1 times r to the 4 minus 1. Plug in what we know. And we get 0.048 equals 6r cubed. Divide by 6. We get 0.008 equals r cubed. Cube root both sides. And we get r equals 0.2. Okay, so that is our common ratio. But now we need to go back. And we need to figure out, use our real a sub 5. So now it's like, okay, JK, JK, JK. We're going to ignore what we just did there. We did that to find our ratio. But now let's use the a sub 5 as it really is. So then we have 0.048 equals a sub 1 times 0.2 to the 4th. Multiply this out, so that's 0.0016. Divide by that, 0.0016, and we get a sub 1 equals 30. That's still not what I'm trying to find. I'm trying to find a sub 4. So now I have r, I have a sub 1, which are both things that I need to use my formula. So now I can go find a sub 4. Okay, so I have 30 times 0.2 to the 3rd power, which is 0.24. Okay, now all this stuff that we're doing, it's really cool, honestly, when it comes to looking into like financial stuff. Like I've recently been investing in like the stocks. And it's so if I have like a 10% return and I put in $1,000, like that is, it depends how much you're like you get certain money back. So like, let's look at this example here. So if Jackson buys a new car for $38,000, so he buys a new Tesla, because I want a Tesla so bad. I'm so jealous of Jackson. And for some reason, the Tesla's only $38,000. But, and it depreciates in value 20% each year. We want to know how much would that car be worth in 8 years. Okay, so his initial value, he bought the car for $38,000. It's depreciating by 20% each year, which means that it's worth 80% of its value after 1 year. So our ratio is 0.8 because that would be 80%. And N is 8 because it's 8 years. Now we have everything we need. Let's plug it into the formula, and we get $7,969.18. So that means after 8 years, his brand new Tesla that was cheaper than the brand new Teslas really are is $7,969.18. Cool. Okay, bye.